We're going to talk about fiber optic a little bit. It is a slightly more technical session. If anybody is continuing from the last one, it's going to be very different. So bear with me. But this is what we have planned today. We're going to talk about fiber optic and its role in the broadcast, especially with the upcoming 12G-SDI 4K. We are all going on to bigger and better formats. So how are we doing that, and why we should be going to fiber optic? That's primarily what we are looking at over here. A little bit introduction about myself. I am a director at Comcon Technologies. The company, we are a 40-year-old company. We started in 1984. We focus heavily on audio, and audio is what led us to work with fiber optic as well. So instead of coming from the video side into fiber optic, we actually branched out from audio. We started looking at audio being transported over fiber for festivals and for various kind of applications. I myself am an engineer. I'm leading the business right now. I take care of technical and marketing business development. So sort of same thing when you're working in a very, very technical company. We also now have a SMPT fiber assembly. So we are going to be manufacturing cables. So this is what gives us the insight into fiber, not just as a user, but as a manufacturer. Excellent. If you're not familiar with fiber, I'm going to touch base upon some of the very, very basic things. It's not going to be heavy on anything, but when we look at today, the media transport is primarily a lot on coaxial. For video, we're focusing more on video. With broadcast, we mostly talk about video, which includes audio, but mostly video. So coaxial cables, again, they have a conductor carrying the signal. So these cables are heavily limited. They are limiting our ability to drive good quality production. They are limiting our ability to create workflows which can help us compete at global levels, especially in sporting events, big festivals, all those kind of things. So these cables, they don't have as much bandwidth as we need nowadays for 4K, for higher quality productions. Even with HD, we are limited to smaller distances. These are electronic signals being transported over copper conductors, so there is degradation. There is a metal conductor carrying signal. There are lots of other electrical interferences. There is signal degradation. We have lots of interferences. Given the world we live in, you have 5G, you have all kind of electromagnetic radiations. So these cables, even though we take a lot of precautions to make sure signal doesn't degrade, it still happens. Which is where fiber comes in. What's the best way to get rid of electrical interference? Get rid of electricity. So that is what we did with fiber. We take the signal, we convert it into fiber optic. It's an optical signal transmission, so there cannot be any electrical interference. So we've solved a huge problem that we've had forever. And this problem has existed in pretty much every audio and video domain. So the minute you get rid of the interferences, you have a higher bandwidth, faster transmission. Light travels faster than a signal on an optical cable. We are able to go longer distances, of course, less degradation, faster speed, we go longer. No science over there. Made from sand. We have lots of this available. It's very, very lightweight. In broadcast, this becomes a very important application feature, because the lighter your fiber optic is, the easier it is for us to use it in field, in sports productions. And immune to electrical interference, of course. So without getting into details of fiber optic, I want to focus on a modern aspect of fiber optic. How what we are doing is different, and how what is currently happening in broadcast is different. Typically, we have a physical contact fiber optic cable. The two fiber optics are touching each other whenever we make any joints, we make any connectors, everything. The fiber optic conductor is touching each other. It's called a physical contact. Nowadays, we have connectors wherein they don't touch. So imagine electrical wires, you always short them in order for signal to transport. But with the new expanded beam, that doesn't happen. That gives us an advantage in terms of no degradation in the connector. If we look at it, we use a lens to expand the fiber optic. It's optics. So we use a lens to expand the surface area. With the expanded surface area, the other conductor also has a lens, and the signal transports easily. This gives us a lot of advantages. We don't have to worry as much about the dust. We don't have to worry as much about the moisture. You can plug unplug the cable 1,000 times and it doesn't go bad. So it takes away the fear of using a fiber optic, that it may not work in the field when I want to use it. You're worried that you have a fiber optic cable, I'm using it, there is dust, what do we do? This cable works. This connection scheme works. And this is what is currently driving the fiber optic expansion. A few basics: multi-mode, single mode. From a user perspective, 300 meters, multi-mode is good, it's cheap, it's readily available. You want to go higher distances, you have to use single mode. It is more difficult to make, so it's costlier, it will not be available as easily. That's the only difference. A lot of different cables are available. We have to get rid of our belief that fiber optic is always brittle, it's always going to be difficult to handle. We have a lot of different cables available nowadays. We have tactical cables available, which are already all shielded and everything. Then we have extreme, which have been ruggedized. We call them extremely rugged cables. We have armored cables through which you can actually drive vehicles on top of them and they'll be okay. And then what we are going to talk about is the SMPT cables. This is what we are recommending in broadcast nowadays. This is the cable that we are now manufacturing, now assembling. And yeah, I'll explain the cable a little bit later. But yeah, so we look at fiber as a very important path in the next step of broadcast growth. We need the bandwidth. The IT industry is already ready with all the bandwidth and processing that we need. We need to have that kind of a bandwidth available in transport also. We cannot depend on coax only to give us the kind of bandwidth we need. The speed of light, we are talking about sports. We're talking about if something happens over there, I want to see it in a different continent at the same time. The more the delay, the bigger the problem I have, which is why we have transcontinental fiber optics. Everything gets transported over there, but imagine at the field play, you don't have any fiber optic. What's the point? So we have to use the speed to our advantage. Immunity to interference. We're starting with something, the signal keeps falling down. We need to get to a point that the signal doesn't go bad, the signal doesn't go lower than our receiver's input stages. We need this to go long distance. So what I'm just saying, you can easily imagine that those transatlantic fiber optic cables are all going to be single modes. And this is what we need. Now this is something that we have already done with fiber optic. If you look at it, you have a fiber optic coming to your home. A lot of us would have a Airtel or a ACT or one of those. Those are all giving you fiber optic direct to your home. This is where we have already invested. India is already moving ahead with fiber optic. 5G networks, Airtel and all, they use a lot of fiber optic in various applications all the way to the towers. So again, it's already done. The IT industry, cloud and edge computing, all the data centers, they are heavily using fiber optics. These people have already established that the industry it's no longer a new technology that is coming in. It is something that is being used. It is something that has been established. We are just opening up, talking about opening a new frontier in our broadcast systems. So, what do we want to do? We are talking about it, but where do we use it? Live production. Even now, we are using fiber, but in a limited way in broadcast productions. If you're watching IPL, it is covered using a lot of fiber, but then what about the other sports? This is something that needs to be ingrained in our broadcast workflows so that we get good quality sports productions for every sport available. Even kabaddi for that matter, every sport. If we are looking at festivals, if we are looking at artists performing, if it's a big artist, yes. If it's a smaller festival, even then. It gives us the ability to carry huge number of audio channels, uncompressed video, and we need that in our live productions. The other advantage is remote productions. Now with remote productions, we don't want to carry everything that we have all the way to all the locations. We want to generate a capability wherein they could be covering this show, lots of cameras, PDCs, whatever they're using, and taking the signal to the studio and producing over there. All we need is a fiber optic connection. So, and these are not, this is again something that is already happening worldwide. We need to move forward to the next step and experiment with this in India as well. These are the next steps. Centralized operations. The production heads need to be able to see what is going on. They need to have a monitoring in centrally. So the central offices need to have better monitoring capabilities using, again, fiber optic, because you cannot transport distance such a long way. So I've been talking about sports. This is the key reason why we started looking into fiber in India. Major event, you can all imagine what the event is. It's a major sports event, needs to be broadcasted to millions and millions of people. I will not say, I mean, anything in India gets broadcasted to a few million at least, but that is a very big event. And the idea is, how do we reduce the delay? I don't want something happening here being seen on a TV 30 seconds later. I want to be able to make sure that maximum coverage is achieved for my signal. I need to distribute the same feed to different broadcast channels internationally. How do we do that? Fiber was the solution. This is how we started looking into it. Zero delays. There is no delay. When we say delay, zero, yeah, it's zero. You can imagine what zero is. It's never entirely zero, but it's a number so infinitesimally small that you don't care about it any longer. Multi-channel support. Why should one cable carry one channel? It should have, we have a very high bandwidth on video or audio or data or anything when we are using a fiber. And resilience. We created a network that can expand. We created a network that can tolerate. We created solutions which are good for a dynamic environment like sports. And that is where this was all done using fiber optic solutions. Just to give you a perspective, we like using other cables, but for example, you will need some cables for audio, some cables for video, some for data. If you're in the broadcast sector, you might be transmitting tally signals. You might need some intercom signals. So we are talking about a few different wires running around. Now in In consumer audio, we like to get rid of all of this by going to RF, but in a broadcast sector, we cannot do this. We need high quality. The RF does not support it. Wireless doesn't support it. But we can go to one cable, one wire, fiber optic. On one fiber, I can transport n number of audio channels, x number of videos, all kind of tallies. I can actually transport data as well, all at the same time. So why are we not doing it? And how can we do it? Initial costs are high. Everybody feels it. I want to do this, but what is the investment required today? Can I do this in piecemeal? But we have to also realize we are the 4th largest manufacturer of fiber cables in the world. Some of our companies are supplying worldwide. 400 million was in 2023. I'm sure it's more than that now. We all feel cable is fragile. It's a fiber optic. That is no longer the case. We have very flexible fiber optic cables. We have rugged cables. We have armored cables, all on fiber. We feel who's going to run the show. What if something happens? Who will do the site work? I don't understand fiber. Here we have to thank the telecom sector, which has invested already heavily into fiber. They have trained engineers. We have a lot of trained manpower available which understands fiber. These guys, they travel with small splicing kits in their bags, and they're able to restore your fiber optic connection to your home. They already are available. There is available skills. Something that was missing, which we recently sorted out, was to have an SMPTE assembly. SMPTE cables are basically fiber optic plus power all in one cable. It allows you to deliver two-way data transfer along with a one-way power delivery. So with one cable, you can run your cameras, you can power them, and you can establish the connection for audio, data, and audio, video, as well as control. So these are special cables. They are designed with fiber and copper in the same jacket. And now we are able to assemble these in India, repair these in India. This is pretty much for the first time. I'm hoping more labs like these will come up in the near future, and we will be able to expand this much faster. Without taking a lot of time, I just want to look at some of the solutions that are available today. We are talking about fiber, but what exactly can we use? Do we have solutions? Do we have products? How does it work? The solution is very simple. We still have the electrical signal. We convert it to fiber optic. We transport it over a fiber optic. We convert it back to electrical. Both sides, it's still the same. We have converters available. We have multiplexers available. Multiplexers basically, okay, so think of different colors. I can put one set of signals on one color, another set of signals on another color, and they can all travel together from the same fiber optic. So we do that. We have those kind of solutions as well. It increases the bandwidth even more. Connectors, cables, systems, everything is started to be available now. Some of you might have seen these in your experiences. These are the connectors that you would have seen are available readily. This is what telecom uses. These are readily available. This is where broadcast comes in. Broadcast typically uses cables which are fiber optic solutions which are highly rugged. So when we look at SMPTE 304, a lot of cameras are designed around these. You take Sony, you take Hitachi, you take any cameras, they will be designed around some kind of they will have at least an option for an SMPTE 304. Again, this is the combination connector which delivers two-way fiber connection along with power delivery. We also have the SMPTE 304 it has been the default standard for almost, I don't know, for multiple decades. But it suffers from the fact that the cables go bad very soon. And you don't know, you always carry a backup. The solution came up by inventing a SMPT 304 cable with a shutter. Simple solution, but it worked. So on came the connectors, optical con connectors from Neutrik with shutters by default. The next level was the expanded beam technology that we saw, wherein you don't even touch the fibers. Those are all, the technology came for military application, and now this is being used in broadcast. So now we have cameras with implementation of expanded beam available for use in broadcast. You can combine two channels of fiber on expanded beam with power. So these solutions are already available in the market. Some of the use case examples, you have a camera that you want to run on an SMPTE. You can always run a straight cable directly. Or, so that's, yeah, you can always run a straight SMPT cable direct from your studio control room to your camera. Or you can use a traditional fiber optic. The simple fiber optic that we are already manufacturing, we are the 4th largest manufacturer of. We can use our standard single mode fiber and use 2 smaller lengths of SMPT cables. We have lots of converters available. Again, this is a technology which is well established. So you're not stuck with an X length of SMPT. You can use any other fiber. These kind of, you have a full length available, great. You're able to invest in it, great. But if you don't have it, you can always convert to a standard fiber. This could be a multi-fiber. And depending on your power requirements, you can either power your camera directly or you can again have power injectors. So 2 different modes, everything is supported. Think of an application and there is 99% a solution is available. This is one of the first few introductions to fiber optic. This is a Lavos system design, and they're covering again a sports production. They need to route so much audio across so many points from the system. They're using fiber optic. All the gear is connected on fiber optic connections, on fiber optic cables. It is all routed to a central mixing console. The sound engineer has entire control over each and every channel. He can route anything over anything. Again, fiber optics are almost always used as a pair, so you always have an in and an out. You have a bidirectional connection. So you have everything. You have microphones, you have speakers, everything being driven from the same network. Mostly the microphones, but yeah. So these kind of system designs is where fiber optic works, because you can depend on the infrastructure that you will create. So we have stadiums which are famous in India. We have stadiums which we can wire up with fiber optic and use that fiber optic for no matter what event, who's bringing in what. It's just a transport mechanism. These work as roads. This is another example wherein we looked at a control room versus a studio connection, and they did not want to run thousands of wires. So we are able to connect the Ethernet, DMX, RS-42, SDI, 4x3G-SDI is basically the 12G-SDI. We are able to connect everything from the studio down the way to the control room and exchange over a fiber optic pair. And this could be something that you've already laid in your building, in your infrastructure at the time of construction. It does not have to be something which is new purchased. If you have a dark fiber, that can be used as well. So yeah. you have a traditional camera or you have a traditional, cameras are the most difficult to adapt, but even in this case, if you have a traditional camera, there are solutions available which will convert the camera into an SMPTE. So if I want to run the same camera across the lens, coaxial cable will not work. You need a fiber optic solution. Anything beyond 80 meters, you need a fiber optic solution for you to be able to depend on it on a 4K for sure. And we are already talking about more than 4K in non-broadcast applications. We have network switches available. Again, standard products available. You can switch between n number of fiber optic connections. Oops. So yeah, I don't want to take a lot of time on this. I could have spoken for as long as I want, but the idea here is that fiber optic is no longer a nascent technology. We bring a new technology, it takes a while to mature. That part is already done. We have solutions, we have equipments, we have multiplexers, converters, everything is available. There are experts in the industry who can help move this forward. The idea is for the users to demand that we want less delay, we want to see things more in real time, and that is where we are looking at fiber optic. Initial costs will be high, but yes, it's still an investment that needs to be made if we have to grow as a broadcast in the country. And that's about it from my side. I don't know if we have time for a question or if we even have a question. Not from you, though. We're good? Yeah, I think we're running late, so if there is anything, I can take it offline as well. Thank you, guys. Thank you.
Will you just go down there? Manoj will hand over.
Yeah, okay. I need
Thank you, Gaurav. I really wish that we had more people sitting here, so sorry about that. And Manoj will hand over a small token of appreciation to you for being here.